right, welcome to the Flow Propagation Extravaganza. In this video, we'll be going through the sample project and all the systems that we have connected information traveling from one family to the next. So this is the sample project building, a small two-story building with some rooftop units, some VAV boxes, some hot water reheat, electric reheat, a handful of different examples to show you guys. So let's talk about duct systems and why. So this ties on to, once again, industry standard shared parameters and standardized connector settings. Here's what we can do with it. So let's look at a modeling plan for ductwork. So why is it beneficial to have proper connectors at these families? Well, because then we can create duct systems, and with duct systems we can inspect them. So let's look at the supply air duct system here, and let's hit inspect. And lo and behold, we have our worst case pressure drop. So this is a great design tool, not even discussing whether Revit is doing these is calculating the fitting losses correctly or not, which I think they do. This is about helping design and pinpointing your worst case, so you can help your fan. Or maybe this is after the fact. A building's in construction and your fan is not able to be balanced. You could use this type of information to pinpoint tight areas in your duct system. So these red arrows are indicating our critical path. And since all of our air terminals now have performance data at them, that makes this information even more valid. So in regards to this specific system, I'm going to close inspector down. Let's look at this duct system, some of the properties. So here's the return air system, or this is the supply air system. So right now we've calculated a static pressure drop of 0.65 inches water column. We have a total CFM for the system, and this number is going to be different depending upon how you created your systems with the VAV boxes. So in this case, we are bypassing the VAV box, and we started by adding the air terminals to the RTU system. And what that allows us to do is to get an accurate static pressure calc as one system. This flow, however, is now incorrect because the VAV boxes have preset connectors that are basically doubling the flow to our unit. So depending upon how you make your system, you have to be aware of that. For like the case of, the extents of this system now, if I show you guys. So as you can see, it's encompassing everything, all the air terminals and the VAV boxes. If we look at the second floor or the first floor in the sample project, you'll see something different. So let's look at this system. So duct system. So now this is a different way to create systems in Revit, and it's just understanding which method you prefer. This is creating a system of the VAV box and any downstream air terminals, and that is a separate system from the RTU system. So now when you do that, the RTU system will not calculate the total static pressure drop, which is ultimately what we want. So like if we look at this duct system, let's go to inspector. So we have our critical path, but of course this ends at the VAV boxes since they're a separate system. What we've done though is we've included the calculated pressure at this inlet plus the coil pressure drop, and we've assigned that at this outlet. So now in that sense, these VAV boxes, regardless of how you make your systems, are going to help calculate total static pressure, because now this duct already knows the static pressure at the inlet to the VAV box. So if we look at the system, this is on the lower level. We're seeing about 1.1 inches water column. These are VAV boxes. To me, that kind of smells in the ballpark. Sure, there's some fittings that don't have any pressure drop, and sure, there's some takeoffs that knowingly don't have any pressure drop, which hopefully Autodesk will fix here. But this is just building upon why it's important to set up these connectors correctly in the same way from any manufacturer. This is what we want to be able to do with your families. So let's move on to gas systems. So let's go to, well, actually, let's go to hydronic systems next. So here's those same VAV boxes. In this case, we have heating, water supply, and return being fed to the boxes. So with calculations and with connectors set up appropriately, now we're able to calculate GPM. So if this VAV box, let's use our input/override parameter. Let's increase it to 700 CFM. Right now the box is auto-sized at a 7-inch. It went to an 8-inch. We now have a higher calculated GPM, which just propagated down the whole system. So that's why these connectors matter. Once again, with proper connector settings, you can get valuable information out of the systems. Like here's the volume of the fluid in the piping system, and here's some static pressure calculations. These I have not reviewed in detail yet, but they're connected and they're working. So I know that's the biggest start. What's next? Let's look at electrical reheat boxes. So let's go to a power plan. This is a working power plan that shows when equipment is circuited and when it's not circuited. So this VAV box is circuited. This one is not, so let's go ahead and circuit that. So it turned green, with our filter. Now the tags are showing the information. So once again, the tags build upon that standardized set of shared parameters and how you can use them. And this electrical connector is now dynamic in certain senses. There's a list of overrides, which we'll talk about more in the user manual. But once again, we're able to get to the apparent load, which is at the connector, based upon a system of calculations. So it's important to have that parameter, apparent load, at the connector. Let's talk about gas systems now. Doesn't look like I have that sheet open yet. So gas systems are a little tricky at the moment since Revit doesn't support all the appropriate data types. But what we're able to do is through the system of tags and information in Revit, we're able to get designers the information they need. So here we have a CFH value that is propagating throughout this piping system. Revit sees that as a GPM, and once we get the appropriate data types available from Revit, we'll correct that. But right now this is just a workflow for users to use to help design. So as equipment changes, as you're editing BTU values at equipment schedules, this is all updating. So for the case of this rooftop unit, let's change it from, I'll move over a little bit here. So let's change it from high heat to a different setting. So here's our high heat setting. Let's change it to medium heat. Let's uncheck that. So we're doing some heat exchanger calculations, which we'll talk about later on. And just like that, we have the tags indicating the scheduled information. We have the propagation updated entirely downstream, and then the meter knows the total connected load. So once again, having proper connectors with the connector types and settings that we've defined, this is what you can do with it. Let's continue on. Let's look at storm calculations. So we'll close some of these views. Let's go to storm riser diagram. So here we're tagging slope and GPM, which we're calculating from the horizontal projected roof area and the rainfall rate. And once again, if someone needed to modify a value, So let's activate this view, select the roof drains. So under flow here, we have our parameters which show up in the schedule here. So say this is a unique case where someone knows, rather than using the rainfall rate, they need to specify a different GPM, or maybe these are siphonic roof drains. So let's put this at 250 GPM. Of course, that's going to propagate down the whole system. So now this GPM can go directly to the storm pipe sizing tables in the code books, and designers can actually use the information. We also have functionality to propagate area through the piping system, kind of similar to the gas piping, where we're putting a value in the GPM spot and then we're using that at the tag, even though so Revit thinks it's a GPM, but the designer gets information that they need. So we have a workflow for that as well. And then, of course, on the domestic side, so if we look at waste and vent riser diagrams, this is all information the designer needs to size the pipe. What is the fixture units? So we've set up all the connectors through the carriers with multiple connectors coming into them. These special split system connectors to separate sanitary from vent, and then a vent sanitary system classification that actually will calculate the flow. And we're able to get our total fixture units from the lower level and the upper level and going through the vent through roof. All dynamic, all easily set up for code and permitting requirements and things like that. So this entire waste system now flows, all the way out to the service. And on the domestic side, once again, just further examples of why it's important for these connector settings and getting manufacturers to set them up the same way. We're able to get fixture units throughout the system, and with Revit we're able to do the calculations based upon whether you have flush valves or flush tanks to calculate the GPM in the system. So this is the sample project, fully connected for you guys to digest and play with and try to break and flex values and find out what happens. It's all here as an example for you guys.